Today we're going to talk about solving systems using substitution. So let's just start with a system here. Y equals negative x plus 4 and y minus 2x equals 1. Now substitution, we all know what to substitute means, is to replace. Well, when we solve a system using substitution, that's exactly what we're going to do. We're going to replace one of our variables with another equation. So for instance, you notice here in this system, we have one that says y equals negative x plus 4, and then we have y minus 2x equals 1. Well, it would be nice if I could replace one of my variables with something. Well, right here it says y equals this. Okay, that's what y is equal to. So what you can do is you can take this and you can substitute it right there. And when we do that, we get this. So instead of this y, I'm going to get negative x plus 4. And then I'm going to write minus 2x equals 1. Okay, so it's this exact same equation, but instead of y, I put this, because that's what y is equal to. So let's go through and take a look at this and simplify it. Any reason for these parentheses? No. So I'm just going to drop them off. Looks like we have some combining like terms we can do. So we get negative 3x plus 4 equals 1. Subtract 4. Negative 3x equals 1 minus 4 is negative 3. Divide by negative 3. X equals 1. Okay, now you might think, well, we're done. Well, we're not, because remember, when we're talking about solving a system, we're looking for a point that they have in common. Or if you think about it in terms of a graph, we're looking for where do these two lines intersect. Well, we have part of the answer. Part of the answer is 1, but then what's the y value? Well, we go back and we're just going to simply take this and we're going to plug it into one of these. Well, I'm going to use this one because that seems easiest. Okay, so I'm going to plug in that 1. So y equals negative 1 plus 4, so y equals 3. And there you go. What point do these two lines have in common? They have the point 1, 3. All right, well, let's try again. Let's try another one. Maybe, hopefully that made sense to you. What about this one? Okay, so now if you notice this one right here, neither one is set equal to x or y. So we're just going to pick. We're going to pick one. And we're going to rewrite one of these equations so it says either x equals or y equals. Now which one do you pick? Well, you pick the one that's easiest for you. You pick the one that's the least amount of effort, if you will. So that's what I would like to do. I'm going to go through and pick the one that's probably make life easiest. So as I look at this, I see this x is sitting here all by itself, so all I'm going to do is I'm going to subtract this 2y to the other side. So if I just kind of squeeze that in, so I'm going to rewrite it down here. So it's going to be x equals negative 2y plus 3. So this is our new system because I've moved that over. Okay, so next step. I'm going to substitute this, because it says x equals up to here. So the negative stays, but then instead of x, I'm going to write this. So negative 2y plus 3 minus 2y equals negative 3. Okay, let's simplify. It looks like I can distribute 2y minus 3 minus 2y equals negative 3. And if notice here, we can combine like terms. Now 2y minus 2y is nothing, so those cancel, and I get negative 3 equals negative 3. Well, let's think back. Okay, what does that mean? So all my variables canceled, and I get a true statement. Well, if you remember back, we said that is infinite solutions. Sometimes we use the word identity. Okay. Well, what does that mean in this case? Well, what that means is that these two equations are essentially the same line. Okay, that's what it means. It means that if there's an infinite amount of solutions, that means there's an infinite amount of points that they have in common. So that means that if one of the lines were to look something like this, then the other line would just lay right on top of it. Okay, it would be an infinite amount of solutions. Okay? All right, let's try one more. Let's try one more. How about this one? This would be a good one for you to try on your own. Just hit pause and see what you can do. Okay, so there's my system, and see if you can solve that on your own. Okay, so first thing is I would get one of the variables by itself. Again, so as I look at this one, I notice that this x is kind of sitting here all by itself. So I'm going to just move or subtract that 3y to the other side. So I get x equals negative 3y plus 21. Okay, so now I'm going to be, if I just rewrite this here for a second, so I have this, 5x minus 2y equals 3. Then I have x equals negative 3y plus 21. So let's do our substitution. So I'm going to take this and substitute it right there. And so my new equation is going to be 5 times, now instead of x, I'm going to put this, negative 3y plus 21 minus 2y equals 3. Okay, so hopefully, let me slide that over. Makes sense so far. Let's distribute. So I get negative 15y plus 105 minus 2y equals 3. Looks like I get some combining like terms. Minus 17y plus 105 equals 3. Let's subtract our 105. Kind of a big number right there, but that's okay. So I get negative 17y equals 3 minus 105 is negative 102. Okay, so what do we get here? Let's divide by negative 17, and hopefully negative 17 goes into negative 102, and it does. It actually goes in 6 times. You might not have known that off the top of your head, but if you do the division, it does go in 6 times. Okay, so we're almost done. So we got half the work. So as I'm looking at my answer, I'll put my answer down here. It's something comma 6. The question is, what's that something? So let's go back to the original. So we can either use this equation, we can use this equation, or we can actually use this one, because all this one is this equation rewritten. So that's what I'm going to do. I'm going to use this one. So I'm going to go x equals negative 3. I'm going to put the 6 plus 21. X equals negative 18 plus 21. So x equals 3. And there you go. And that's how you solve systems using substitution.